Hello friends, welcome to my second lecture on two-phase method. Here we shall discuss some more examples on solution of linear programming problem by two-phase method. Let us consider z equal to 3x1 plus 2x2 plus x3 plus 4x4. We have to maximize this objective function subject to the constants 4x1 plus 5x2 plus x3 plus 5x4 equal to 5. 2x1 minus 3x2 minus 4x3 plus 5x4 equal to 7, x1 plus 4x2 plus 5x3 minus 4x4 equal to 6, x1, x2, x3, x4 are greater than or equal to 0. Now, since these constants are of equality type, okay, equality here, equality here, equality here, we will consider the artificial variables a1, a2, a3. So, introducing the artificial variables a1, a2, a3, the phase 1 problem in standard form becomes maximum of z star equal to 0 into x1, 0 into x2, 0 into x3, 0 into x4, minus a1, minus a2, minus a3. To the artificial variables, the coefficients are taken as minus 1, while for the decision variables x1, x2, x3, x4, the coefficients are taken as zeros. So, subject to the constants are now equations are 4x1 plus 5x2 plus x3 plus 5x4 plus a1 equal to 5 and 2x1 minus 3x2 plus minus 4x3 plus 5x4 plus a2 equal to 7, x1 plus 4x2 plus 5x3 minus 4x4 plus a3 equal to 6. Now, where x1, x2, x3, x4, a1, a2, a3 are greater than or equal to 0. Now, setting the variables non-basic variables x1, x2, x3, x4 equal to 0, we have the basic variables a1, a2, a3 equal to a1 is equal to 5, a2 equal to 7, a3 equal to 6, and therefore, z star is equal to minus a1 minus a2 minus a3. So, minus 5 minus 7 minus 6, that is equal to minus 18. So, z star is equal to minus 18. Now, let us first find the first simplex table. So, here Cj's are the coefficients of the variables in the objective function. So, we have 0 into x1, 0 into x2, 0 into x3, 0 into x4, minus a1, minus a2, minus a3. So, we have 0, 0, 0, 0, minus 1, minus 1, minus 1, and the basis variables are a1, a2, a3, whose coefficients are minus 1, minus 1, minus 1 in the objective function, and this is the matrix 4, 5, 1, 5. They are the coefficients of x1, x2, x3, x4, and then the coefficient of a1 is 1, coefficient of a2 is 0, coefficient of a3 is 0, and b is equal to 5. Okay. And then in the second equation is the coefficient of x1 is 2, coefficient of x2 is minus 3, coefficient of x3 is minus 4, coefficient of x4 is 5, coefficient of a1 is 0, coefficient of a2 is 1, coefficient of a3 is 0, and then the constant on the right side is 7. Similarly, the third equation, the coefficient of x1 is 1, coefficient of x2 is 4, coefficient of x3 is 5, coefficient of x4 is minus 4, the coefficients of a1 and a2 are zeros, and coefficient of a3 equal to 1, and the constant is 6. Now, we can find zj star, which is sigma cb aij. So, sigma cb aij if we find, then here you can see minus 1 into 4 is minus 4, minus 1 into 2 is minus 2, minus 1 into minus 1 is minus 1. So, minus 4 minus 2 minus 1 becomes minus 7, okay. And when we get capital Cj, which is Cj minus zj star, we get 0 minus minus 7. So, we get 7 here. Similarly, in the x2 column we have 5. So, minus 1 into 5 is minus 5, minus 1 into minus 3 is 3, minus 1 into 4 is minus 4. So, minus 5 minus 4 minus 9, minus 9 plus 3 is minus 6. So, this is minus 6, and when we subtract minus 6 from 0 we get 6. Similarly, we can get here in the column corresponding to x3 we get zj star equal to minus 2, in the column corresponding to x4 we get zj star equal to minus 6, and in the column corresponding to a1 we can see minus 1 into 1 is minus 1, minus 1 into 0 is 0, minus 1 into 0 is 0. So, the total is minus 1. When we subtract minus 1 from minus 1 we get 0 here, and similarly for A2 we get zj star as minus 1, and minus 1 when we subtract from minus 1 again we get 0. In the column corresponding to A3 again we get Z star equal to minus 1. When we subtract minus 1 from minus 1 we get 0. Now, we can see here Cj is greater than 0 in the column corresponding to x1, x2, x3, x4. Okay. The maximum of all these positive values is 7. So, this is key column, this one is key column. Okay. And so, the elements of the key column 4, 2, 1, okay, 4, 2, 1 are there. We divide B value by 4 to get 5 by 4, divide 7 by 2 we get 7 by 2 here, divide 6 by 1 we get 6 here, and then we have to see which one is the minimum. So, 5 by 4 clearly is minimum, and therefore, this is key row. Okay. So, this is key row and this is key column. So, their intersection is this key element 4. Okay. Now, once we have key element, this means that x 1 is incoming variable and A 1 is outgoing variable. So, in the next simplex table A 1 will be going out, okay, x 1 will be coming in, and the column corresponding to A 1 will also be removed. So, we have the following simplex table. We see here we have, instead of A 1 we have x 1 here, the coefficient of x 1 is 0. So, we put here 0, A 2, A 3 are as such, and then what we do is A 1, the column corresponding to A 1 is deleted here, and now what we do, the key row elements are divided by the key element. Okay. So, we divide key row elements by 4 and we get 1, 5 by 4, 1 by 4, 5 by 4, and we get here 5 by 4. Okay. So, the new row is 1, 5 by 4, 1 by 4, 5 by 4, A 1 column is not there, 0, 0, 5 by 4. Okay. Now, with the help of this new row, okay, new row where we have made the key element 1 by dividing by 4, with the help of this we make the entries in the key column, other entries in the key column as zeros. So, other key entries in the key column are 2, here we have 2, here we have 1. Okay. This means that we multiply the row, this row by 2 and subtract from the second row, and then to make the this entry 0 we just subtract the this row from the third row. Okay. So, let us multiply the elements 1 5 by 4, 1 5 by 4, 1 by 4 and 5 by 4, and we get 0, 0, 5 by 4. Okay. These elements we multiply by 2 and subtract from the second row. So, when we multiply these by 2, okay, we get 2, 5 by 2, and when we multiply by 2 we get 1 by 2, and then we get 5 by 2, 0, 0, 5 by 2. Okay. Now, this is this we subtract from the second row elements. So, second row elements are 2 minus 3 minus 4, 4 5, 2 minus 3 minus 4, 5 0 1 0 7. Okay. So, 5 0 1 0 7. Okay. Now, let us see. So, we subtract these values, okay, from the corresponding values here. So, when we subtract this 2 from this 2 here we get 0. Okay. So, we get 0 here, then 5 by 2 we subtract from minus 3. So, minus 3 minus 5 by 2. Okay. Then minus 4 we subtract half. So, minus 4 minus half, then 5 minus 5 by 2, then 0 minus 0, then 1 minus 0. Okay. This element will not be there. So, what we will do, 2 minus 2 is 0, minus 3 minus 5 by 2, then minus 4 minus 1 by 2, then 5 minus 5 by 2, okay, then 1 minus 0, 1 minus 0, okay, and then we get 0 minus 0, and then we get 7 minus 5 by 2. Okay. All right. So, we get 0, and then we have minus 11 by 2, minus 9 by 2 and then we get 5 by 2, 1, 0 and then we get 9 by 2. So, you can see here 0, minus 11 by 2, minus 9 by 2, 5 by 2, 1, 0, 9 by 2. Okay. And from the third row we subtract just this row, this one. Okay. And third row is what? 1, 4, 5 minus 4. Okay. A1 we have not, don't have to take. So, 1, 4, 5, 1, 4, 5 minus 4, 1, 4, 5 minus 4, A1 is deleted, 1, 4, 5 minus 4, 0, 1, 6 we have, 0, 1, 6. So, from this we simply subtract the first row, that is 1, 5 by 4. Okay. So, 1 minus 1, 4 minus 5 by 4, then we get 5 minus 1 by 4, then we get minus 4 minus 5 by 4, then we get 0 minus 0, 1 minus 0, 6 minus 5 by 4, and what we will get here? 0 and this will be 16 minus 5. So, we get 11 by 4. Okay. So, 0, 11 by 4, and here 5 into 4 is 20, 20 minus 1, so 19 by 4, and here we get minus 16 minus 5 minus 21 by 4, here 0, here 1, here 24 minus 5, so 19 by 4. So, we get this 0, 11 by 4, 19 by 4, minus 21 by 4, 0, 1, 19 by 4. Okay. Now, we find ZJ star. ZJ star is sigma CB Aij. So, 0 into 1, 0, minus 1 into 0, 0, minus 1 into 0, 0. So, we get 0, 0 minus 0, 0. So, this is 0. Okay. Then 0 into 5 by 4 is 0, minus 1 into minus 11 by 2 is 11 by 2, and then we get minus 1 into 11 by 4. So, minus 11 by 4, and then 11 by 2 minus 11 by 4 is 11 by 4. So, we get 11 by 4 here, 0 minus 11 by 4 is minus 11 by 4, and similarly we can calculate ZJ star here for x3 column. It is minus 1 by 4, when we subtract from 0 it becomes 1 by 4, and here in the x4 column ZJ star is 11 by 4, when we subtract from 0 we get minus 11 by 4. Here in the A2 column it is minus 1, when we subtract from minus 1 it is 0. Here in the A3 column it is again minus 1, when we subtract from minus 1 we get 0. Okay. Now, so the Cj is positive in the column corresponding to x3, in the column corresponding to x4, no, in the column corresponding to x3 it is positive, in the other columns it is less than or equal to 0. So, Cj is greater than 0 in the x3 column. So, this will be key column, this is key column. Okay. Now, divide the elements in the B column by the corresponding values in the column that is key column. So, 1 by 5 by 4 is divided by 1 by 4, we get 5. 9 by 2, when we divide by minus 9 by 2 we get minus 1, that is negative value, this is minus 1, okay, negative value, and then we divide 19 by 4 by 19 by 4 and we get 1 here. Okay. So, we have to now consider minimum value of among the positive values in the theta column. So, minimum value is 1 in the among the positive values, they are 5 and 1. So, minimum value is 1. So, this is key row, this is key row, and at the intersection of key row and the key column we get 19 by 4. Okay. So, 19 by 4 we divide, okay, this means that x3 will be incoming variable and a3 will be outgoing variable. In place of a3 we shall now have x3 in the new in the next table, and the coefficient of x3 is 0. So, minus 1 here will be replaced by 0. Okay. After that we will make the key element which is 19 by 4 as unity by dividing the entire key row by 19 by 4. Okay. So, let us see what happens in the next table. So, we have CB 0 minus 1, we have 0 minus 1, A3 is now becoming x3 and here the value becomes 0. So, we get 0 here and we get x3 here, and okay, and we get x1, x2, x3, and A3 is now removed, the column corresponding to A3 is now removed, we have just column corresponding to the artificial variable A2. Now, we divide the key row elements by key element. So, key row elements are divided by 19 by 4. So, here we will get 0, here we will get 11 by 19, here we will get minus 21 by 19, okay, and here we get 0, here we get 4 by 19, here we get 1. So, let us see. So, the column the key row, now the new row becomes this 0 11 by 19. So, this is 11 by 19, this is 1, okay. This is minus 21 by 19, this is 0, this is 4 by 19. Oh, okay, because A2, A3 is not there, okay. So, this is no longer there. So, this is 0, then we come to this. So, 19 by 4 divided by 19 by 4 becomes 1. So, this is becoming 1, okay. A3 column is not there. Now, with the help of this 1, okay, this is key column. So, with the help of this one, we make this entry and this entry zeros, okay. So, we multiply the new row, this one, the new row is this row, okay. We multiply by 9 by 2 and add to the second row, okay. Now, what are the elements of this row? 0, 11 by 19, and then we get 1, we get minus 21 by 19, okay. We get 0, we get 1, okay. And what are the elements there? We do not have to consider A3 column, okay. So, A3 column we do not have to consider. So, 0, minus 11 by 2, okay, minus 9 by 2, and we get 5 by 2, we get 1 here, this we do not have to consider, and we get 9 by 2 here, okay. So, 0 minus 11 by 2 minus 9 by 2, 5 by 2, 1, 9 by 2, okay. So, we have to make this entry 0, okay. This entry 0 we have to make. So, we multiply it by 9 by 2 and add to this. When we multiply by 9 by 2, what it becomes? 0, 11 by 19 into 9 by 2, okay, and we get 9 by 2 there, and we get minus 21 by 19 into 9 by 2 here, and we get 0, we get 9 by 2 here. Now, we add this to this row, okay. So, when you add these row to this row, what you will get? 0 plus 0 is 0, minus 11 by 2, and we get 99 by 38. Okay, 9 by 2 plus 9 by minus 9 by 2 is 0. This is 9 minus 189 by 38 plus 5 by 2, and then we get 0 plus 1, and then we get 9 by 2 plus 9 by 2. So, we get 9. Okay. So, what is this? So, 0, this is 38. So, 19 into 11. So, 11 into 19. So, how much is that? $209. Okay. So, minus 209 plus 99. Then 0, here we get 38 and we get minus 189, and then we get 19 5 ja 19 into 5 ja 95 1 9. So, how much is that? 0 and minus 110, and here we get no. Okay, so what we will get? Yes, 0 minus 55 by 19, minus 55 by 19, 0. This is minus 47 by 19. This is 1. This is 9. Okay, so that is how we get this, and then we make this entry 0. This to make this entry 0, what we have to do? We have 1 by 4 here. Okay, so we multiply this row by 1 by 4 and add here. No, subtract there. This is 1 by 4. So, we multiply by 1 by 4 and subtract. So, we multiply this by 1 by 4, this row by 1 by 4 and subtract from the elements of this row. Remember that A3 is not there, A3 column. Okay. So, then we will get the new row as this 1 21 by 19 0 29 by 19 0 1. Okay. Now, we find ZJ star. ZJ star is for x1 it is 0, for x2 it is 55 by 19, for x3 it is 0, for x4 column it is 47 by 19, for A2 it is minus 1 and for B it is minus 9. Okay. When we consider Cj, capital Cj, we get Cj minus Zj star. So, it is 0 minus 55 by 19, 0 minus 47 by 19 and it is 0. Okay. So, what we see all Cj's are less than or equal to 0. Therefore, an optimal BFS to the auxiliary problem has been attained. Okay. But the artificial vector you can see A2, artificial vector A2 appears in the optimal basic at a positive level. We can see in the B column the value is 9. So, at a positive level it is occurring, hence the auxiliary as well as the original LPP does not possess any feasible solution in this case. Okay, now, let us consider second problem, z equal to 3 x 1 plus 2 x 2 plus x 3. We have to maximize these objective functions subject to the constants minus 3 x 1 plus 2 x 2 plus 2 x 3 equal to 8, minus 3 x 1 plus 4 x 2 plus x 3 is equal to 7, x 1 x 2 x 3 greater than or equal to 0. Okay, so, what we will do, we will consider two artificial variables here, okay, A1 and A2, okay, and the given LPP then will become Z maximum of Z star equal to 0 x 1, 0 x 2, 0 x 3 minus A1 minus A2, and we will have here minus 3 x 1 plus 2 x 2 plus 2 x 3 plus A1 equal to 8, and this equation will become minus 3 x 1 plus 4 x 2 plus x 3 plus A2 equal to 7. Okay. So, x 1 x 2 x 3 A1 A2 greater than or equal to 0. Now, let us take the non basic variables x 1 x 2 x 3 to be equal to 0, okay, but we get A1 is equal to 8, A2 equal to 7, which is starting BFS. Okay. So, Cj is now coefficients of the x 1 x 2 x 3 A1 A2. So, they are 0 0 0 minus 1 minus 1. Okay. This is Cj. Bj, the decision variables are x 1 x 2 x 3, basic variables are A1 A2. Okay. So, the coefficients of A1 A2 here are minus 1 minus 1, and this is your column corresponding to x 1 minus 3 minus 3, column corresponding to x 2 2 4, for x 3 it is 2 1, for A1 it is 1 0, for A2 it is 0 1, and column of constants is 8 7. Okay. So, 8 7 we have. Okay. So, now what we notice is that minus 1 into minus 3 is 3, minus 1 into minus 3 is 3, 3 plus 3 is 6. So, we get Zj star equal to 6. So, Cj equal to 0 minus 6 is minus 6, okay, and then here we get minus 1 into 2 is minus 2, minus 1 into 4 is minus 4. So, Zj star becomes minus 6. When we subtract minus 6 from 0, we get 6 here. In the column for x 3 we get Cj equal to 3, and the column for A1 we get Cj equal to 0, for the column A2 we get Cj equal to 0. So, Cj is positive in the column x 2 and in the column x 3, but the maximum value is 6 of these two positive values. So, this column is the key column. Okay. Now, we have to find the key row. So, divide the elements of the B column by the corresponding values in the key column. So, 8 by 2 gives 4, 7 by 4 gives 7 by 4. Okay. Now, of these two values of theta, we see that 754 is the minimum. So, this row is the key row, and the intersection of key row and the key column is this element. So, this element is the key element is 4. X 2 is then the incoming variable, A 2 is the outgoing variable. So, this new in the new table what we will have, Cb will be minus 1, okay, basis will be A1 and A 2 will be replaced by x 2, okay, coefficient of x 2 is 0, okay, and what we have here the key row elements will be divided by 4 to make this key element unity. So, we will have here minus 3 by 4, we will have here 1, we will have here 1 by 4, and we will have here now A 2 is going out. Okay. So, A 1. So, A 1 element this will become 0, A 2 will not be there, B will become 7 by 4. Okay. This is right. So, this is x 1, x 2, x 3, and then we get A 1 and we get B. Okay. So, now with the help of this 1 we will make this element 0. Okay. So, we multiply it by 2 and subtract from this row. Okay. So, when we multiply it by 2 this becomes minus 3 by 2 and we subtract from minus 3. So, what we get minus 3 plus 3 by 2. Okay. And this becomes 0. And here we will get 2 minus 2 we are multiplying to 1 by 4, 1 by 2 we are subtracting from 2. So, 2 minus 1 by 2, and here we will get 1 minus 0 into 1 minus 0 into 2. So, that will be 0 1, and then here what we will get 8 minus we are subtracting 7 by 2. We are dividing it by 4 then multiplying by 2. So, we are dividing 8 minus 7 by 2. So, this will be how much? This will become minus 3 by 2. So, this will become minus 3 by 2, this will become minus 3 by 2, then we will have 0, then we have 3 by 2, and then we have 1 here, then we have 16 minus 7 9 by 2 here. So, this is x 1, x 2, x 3, A 1 and B. Okay. So, let us see now. So, we can see this x 1, x 2, x 3, A 1 B, and these are the elements in the new row modified after key row after we have divided by 4. So, minus 3 by 4, 1 1 by 4, 0 7 by 4. So, this is 7 by 4. Now, we can see we again get C Z j star. Z j star now will be minus 1 into minus 3 by 2, 3 by 2, and this is 0. Okay. So, we get 3 by 2 here, 0 minus 3 by 2 gives minus 3 by 2, then minus 1 into 0 is 0, 0 into 1 is 0. So, we get 0 here, 0 minus 0 is 0, then we get minus 3 by 2 and minus 3 by 2 is this. So, when we subtract from 0 it gives 3 by 2, and minus 1 into 1 is 1, 0 into 0 0. So, this is minus 1 subtracted from minus 1 gives 0. Now, we can see G j is positive in this column. Okay. So, this is key column, and 3 by 2. Let us find the key element. Now, we divide by 3 by 2 this 9 by 2, 9 by 2 over 3 by 2 gives 3, and 7 by 4 divided by 1 by 4 gives you 7. So, minimum is 3. So, this is key row. So, this is key element. So, we divide by key element. Okay. And more before that what we notice that now x 3 will be incoming, A 1 will be going out. So, what we will have in the new table C B basis. So, here in place of A 1 now we will have, so x 3 will be coming in, A 1 will be going out. Okay. So, x 3 and the coefficient of x 3 is 0, x 2 the coefficient of 0 x 2 is 0, then we have x 1, x 2, x 3. Okay. A 1 will not be there anymore. So, B, and then we will have we are dividing by 3 by 2. Okay. So, 3 by 2 means this is minus 1, 0, then 1, and then we divide by 3 by 2. So, it will become 9 by 2 over 3 by 2. So, it will become 3. Okay. And with the help of this element now 1 we will make this element 0. Okay. So, we multiplied by 1 by 4 this row and subtract from this row. So, when we multiply by 1 by 4 this becomes minus 1 by 4, minus 1 by 4 we subtract here. So, minus 3 by 4 plus 1 by 4 we get, and here what we will get, we are multiplying it by 1 by 4 and subtracting from this. So, we get this will remain 1, this will become 0, and this will become 7 by 4 minus we are multiplying by 1 by 4. So, 3 by 4. So, how much is that? This is minus 2 over 4. okay, minus 2 over 4, this is minus half, 1 0, and then this 7 minus 3 4 by 4. So, this is 1. Okay. So, what we get, let us see, minus 1 0 1 3, okay, minus 1 0 1 3, then minus half 1 0 1, minus half 1 0 1. Okay. Now, let us find z j star. So, z j star 0 into minus 1 0, this is 0. So, this 0, 0 into 0, 0 into 1, so 1, so these are all zeros. Okay. And then C j minus z j star. So, 0 minus 0, 0 0 0. Okay. Now, C j is less than or equal to 0. So, this table gives us the optimal solution. Okay. And z maximum star, z maximum, z star is what? Z star is this one. Okay. X 1 into 0, x 2 into 0, x 3 minus a 1 minus a 2. Okay. So, from z star equal to 0 into x 1, 0 into x 2, 0 into x 3 minus a 1 minus a 2. Now, a 1 a 2 are zeros, okay, x 1 x 2. Okay. So, x 3 is 0 6 and x 2 is 1, x 1 is 0. So, we get 0, x 1 is 0, x 2 is 1. So, 0 into 1 is 0, x 3 is 6. So, again we get x 3 is 3. So, we get 0, a 1 a 2 are also zeros. So, z j star is 0. So, this is 0 and no artificial variable. You can see no artificial variable appears in the basis. Thus, an optimal basic feasible solution to the auxiliary problem and therefore, to the original problem has been attained. Okay. So, what we do now, considering the actual costs associated with the original variables, okay, we find maximum value of z. Z is equal to 3 x 1 plus 2 x 2 plus x 3. This was z. 3 x 1 plus 2 x 2 plus x 3, and then we get 0 into a 1, 0 into a 2, and the basic feasible solution found at the end of phase 1 is used as a starting solution for the original problem. Okay. So, basis our x 3 x 2, okay, this x 3 x 2. Okay. The coefficient of x 3 x 2 are now will be written here in the CB column. Okay. So, they are x 3 coefficient is 1, x 2 coefficient is 2, and the remaining table, this will be remaining as such, x 1 x 2 x 3 minus 1 0 1 3 minus half 1 0 1, and then let us find now z star, z, okay, z is sigma C B A I j. So, 1 into minus 1 is minus 1, 2 into minus half is minus 1. So, we get z as minus 2, and then here 1 into 0 is 0, 2 into 1 is 2, okay, then 1 into 1 is 1, 2 into 0 is 2 0. So, we get 1 here, 1 into 3 is 3, okay, and then 2 into 0, 2 into 1 is 2. So, 2 plus 3 equal to 5, 1 into 3 is 3, 2 into 1 is 2. So, here we should have 5. Okay. So, now what we will have, C j equal to C j minus z. So, we will 3 minus minus 2, that is means 3 plus 2. So, we get 5 here, 2 minus 2 is 0 and 1 minus 1 is 0. Okay. Now, we can see C j is positive in this column. Okay. So, this is key column. Okay. We divide by minus 1 this 3. So, we get minus 3, and we divide 1 by minus half. So, we get minus half. So, these are negative values. Okay. These are negative values, and therefore, because of this 5 being positive, x 1 is incoming vector, but all the elements of this column are negative, as we can see. Okay. All the elements are negative. So, we cannot select the outgoing vector, okay, because theta outgoing, for selecting outgoing vector, we should have positive value of theta, okay, from which we get the minimum value, positive value of theta. So, there is no minimum positive value of theta. So, we cannot select outgoing vector, hence in this case the solution is unbounded. Okay. So, that is all in this lecture. Thank you very much for your attention.